Okay, so in this video, we'll see how to find out the max number of edges that can be possible in an n vertex graph. So here I have a picture of a five vertex graph. The vertices are A, B, C, D, and E, and I have five edges: A, D, C, D, B, E, B, D, and D, E. Right. So to find out, so in this graph I have five edges, but the question is like, what are the max number of edges that you can possibly have? Uh, okay, so the way to think about this is, if you want to form an edge, you need two vertices. And what are the number of ways that you can select two vertices from n vertices? And the answer for that is NC2 ways. So you can uh, select two vertices from n vertices in NC2 ways. Right. Once you select two vertices, you just put an edge, and those will be the number of edges. So you can have max of NC2 edges, and this is nothing but n factorial divided by n minus 2 factorial times 2 factorial, and which is also n times n minus 1 times n minus 2 factorial, uh, and this will be equal to n times n minus 1 divided by 2. So these are the max number of edges that you can have in a n vertex graph. Let's also see a second way of doing this. A second way of coming to the same solution is, you have n vertices in the graph, and if you start from the first vertex, so what are the max number of edges that you can have from the first vertex? So from the first vertex, you basically can connect to the remaining n minus 1 vertices, so you'll have n minus 1 edges uh, from the first vertex. You can do the same for the second vertex. So for the second vertex, you can have n minus 1 edges, and you can do this for the remaining n edges, remaining vertices. And since you have n of n vertices, if you want to get the max number of edges, you just sum. So if you sum them, it will be n minus 1 uh, times n. Okay. But if you okay, but what happens is, let's assume that m max number of edges is m. So if you count, if you just add all these edges, what you will be doing is, you will be counting edges twice, right? If you go back to the diagram, uh, so for example, when you're counting from the vertex A, so you will count the edge from A to D when you are counting from A, and you will also count the same edge when you are counting the edges from vertex D. So basically, you have double counted it, right? So what you get when you sum all these edges is, like, because you are counting it twice, what you get is m plus m, right? And that's why max number of edges is n minus 1 times n divided by 2. You can also look at this visually. So you to form an edge, you need to select two vertices, and so the number of ways that you can select two vertices, you can consider this as a two-step experiment, where in the first step you are selecting one of the vertices. For example, in the above example, you have five ways you can select the first edge, first vertex. So once you selected the first vertex, to select the second vertex, you'll have four options now. So this will be B, C, D, E. And similarly, in the first step, you've selected the vertex B. you'll have four options in the second step, uh, which will be A, C, D, and E, right? And then you basically count the number of uh, leaves, and this will turn out to be in this example 5 times 4. And then you can see here that you will be counting the edges twice, because uh, if you take this example where I'm selecting the vertex A first and then the vertex B, so that I get the edge AB, right? But I'll select the same edge if I select the edge B, select the vertex B first, and then select the vertex A. So the edge that I get here is BA, and uh, because the edge A to B and the B to A are the same because it's an undirected graph, so we are basically counting each of the edge two times. So you need to accommodate that, and then that will be 5 times 4 divided by 2. And similarly, if you have an n vertex graph, so in the first step you will have n options, and in the second step you will have n minus 1 options to select the vertex. And if you count the total number of leaves, it's going to be n times n minus 1, and then you accommodate for the double edges. So the total number of max number of edges that are possible in a n vertex graph will be n times n minus 1 by 2.